Welcome back everybody. In today's session we will discuss about SJF scheduling algorithm. Right? In the previous section we have discussed about FCFS scheduling algorithm that was called as first come first serve algorithm. Right? In that the process which arrives first that will be executed first. Coming to SJF scheduling, it is known as shortest job first scheduling. So here what happens, the process with the smallest CPU burst requirement will be given the CPU first, right? Like that, the process with the smallest CPU burst time will execute first. So advantage of this is that here we will not have convoy effect. So we have discussed what is convoy effect in the last session. The convoy effect means what? The process with the smallest CPU burst will wait for the longer process to complete the execution, and delay was also high, right? So in SJF scheduling algorithm, we will have processes. With processes, we will have burst times. So in the burst times, we will select the process with the smallest burst time to execute first, right? If two processes are having same burst time, then we will follow FCFS scheduling algorithm. Means among those two, the process which comes first will be executed first, right? So we will see an example here. For example, consider we are having four processors. Four processes, I am writing here, P1, P2, P3 and P4, right? So consider here we are not considering arrival time, so directly we are considering the bus times, right? For example, P1 requires the bus time of 6 seconds, P2 requires the bus times of 8 seconds, P3 requires the bus time of 7 seconds, and P4 requires the bus time of 3 seconds, right? Okay, so these are the processes P1 to P4 at any given time. They are in the ready queue and their bus time requirements are these. P1 requires 6 seconds, P2 requires 8 seconds, P3 7 and P4 3 seconds, right? So among these four, which one will be executed first? According to the definition of SJF, right, the process with the smallest burst time requirement will be executed first, right? So which one is having the smallest requirement among these four? The smallest requirement we have for P4, right? Its bus time requirement is, okay, 3, right? So from 0 onwards it will start the execution. So till the third second it will finish the execution, right? So P4's execution is over. So right, in the next in the queue, which process is pending? So P4's execution is over. P1, P2, P3, among these three, okay, we are having the less requirement for P1. So next after P1, P4, P1 will start the execution the third second and it will continue for 6 seconds, right? It will continue for 6 seconds. So it will stop the execution at the how much time? At the 9th second it started the execution. For 6 seconds it will continuously execute, and at the 9th second it will finish the execution, right? So after that who will start the execution? After that, okay, so P1 is also over. Now P2 and P3 are pending. So among those two, as we can see, P3 is having less amount of bus time requirement, right? That is 7. So P3 will start the execution at the 9th second. Its bus time requirement is 7 seconds. So it will start the execution at the 9th second and it will continue for 7 seconds. So where it will stop the execution? 9 plus 7, that is at 16th second it will stop the execution, right? So now P3 is also over, so only P2 is pending, so P2 will start the execution, right? So when it will start the execution? It will start the execution at the 16th second. right? It will continue for 8 seconds till its execution is over, right? When it will stop at the 16th second, it has started, and for 8 seconds it is continuously executing. So 16 plus 8 means, so it will start the execution at the 24th second, right? So this is the GNAT chart. Okay, so this is the SJF GNAT chart, simply GNAT chart. So from this we will calculate the turnaround time and the waiting times of P1, P2, P3, P4, right? So for example, consider we will write the processes here: P1, P2, P3 and P4, right? So here we will write waiting time. First we will calculate waiting time, okay? Then we will calculate turnaround time. So waiting time here is how much time the process is waiting in the queue, ready queue, that is known as waiting time, right? So we have discussed in the last classes also waiting time, turnaround time. Turnaround time means when it is finishing the execution, that is known as turnaround time, right? So P1, it started the execution at the 3rd second. So we can say that it is waiting for 3 seconds, right? So here its waiting time will be 3. Coming to P2, it is starting at the 16th second, right? And coming to P3, when it is starting the execution, it is starting the execution at the 9th second, right? And coming to P4, when it is starting the execution, it is starting at the 0th second only. So these are the individual waiting times of P1, P2, P3, P4. P1 waiting for 3 seconds, okay? P2 waiting for 16 seconds, and P3 waiting for 9 seconds, P4 waiting for 0 seconds, right? It is not waiting. So coming to turnaround time, when they have finished, P1, coming to P1, see when it is finished the execution. So it started the execution at the 3rd second, but it is finishing at the 9th second, right? So its turnaround time will be 9. Okay, P1. Coming to P2, it is started at the 16th second and it is finished at the 24th second. Okay, and coming to P3, it started the execution at the 9th second and finishes at the 16th second. And P4 finishes at the execution at the 3rd second, right? So we can calculate average waiting time from here. Okay, what is the average waiting time? Average waiting time will be, okay, 3 plus 16 plus 9, right? And plus 0 you can write. This is for P4. So total number of processes are 4. So we divide the sum by 4. So how much we will get? Okay, 13 plus 16, that is 19. 19 plus 9, 26, right? 26 divided by 4. So how much we will get? Right, 19 plus 4, 28, right? 28 divided by 4. So this is equal to 7. So the average waiting time is 7, right? So you can also calculate turnaround time like that. The average turn, right? For example, we will circle this. This is the average waiting time in this example. So this is enough. You can also calculate average turnaround time, ATT. So how much this is? Okay, this is equal to 9 plus 24, 9 plus 24, 16 plus 3 whole divided by 4, right? So it will be equal to what? 9 plus 24, 52, right? So this is equal to 52. 52 divided by 4. So this is equal to, okay, 52 divided by 4, this is equal to 13. Right? So this is average turnaround time. So mostly we will consider average waiting time. It should be very less. Turnaround time should also minimum. Right? So this is preemptive shortest job first algorithm. So this is called as preemptive because once the process started the execution, it will never stop the execution. Right? So already we have written here SJF is of two types, non-preemptive and preemptive. In non-preemptive, CPU will release the process will release the CPU only after its execution is over, right? Then only it is going to release the CPU. This is called as non-preemptive scheduling algorithm. So in preemptive scheduling algorithm, CPU can, in the middle, it can release the processor CPU before finishing the execution. Either it can release the CPU voluntarily or forcefully it can terminate the execution and CPU will be given to next process, right? So this is also called as, this type of SJF is also called as shortest remaining time first scheduling. Okay, shortest remaining time first scheduling. Regarding this with example we are going to discuss in the next class. So the brief of the today's class is that, okay, we have discussed about SJF scheduling. It is called as shortest job first scheduling algorithm. The process with the minimum CPU burst time will be given the CPU first, right? And we will calculate average waiting time. We have calculated average turnaround time also we have calculated. So in this we will not have convoy effect. Why? Because smallest processes will not wait. Smallest processes will be given the higher priority to execute first, right? Regarding shortest remaining time for scheduling algorithm or preemptive SJF scheduling algorithm, we will be discussing in the next class, next session. So kindly stay tuned. Thank you all.